Okay, this video is for the Flick Your Bic makeup lab. So in this lab, what we did is we took a Bic lighter and we recorded the mass before we let out any gas. And what we're trying to do is we're trying to find a molar mass of a gas. To get a molar mass, basically you need to know two things. To get a molar mass, you need to know the grams in 1 mole. So you're going to take the grams divided by the moles. All right. So what we did is we took a Bic lighter and we found the mass of the Bic lighter before we released any gas, and we recorded it in a data table. So here's the mass before the gas was released. Then we took the lighter and we took this lighter and we took it and we put it underneath this gas tube, underneath the water, and we released gas and it displaced the water, and we collected the gas by water displacement until it reaches between 70 and 90 milliliters. And with this made up data here, this person collected 90 milliliters. Okay? And then after we collected the gas, we remassed the lighter and found that it was 21.02 grams. So now, to get a molar mass, remember we need to know the grams. So what we can do is we can find the mass of our gas by taking 21.23, that's before, subtracting 21.02. And the difference would be the mass of our gas. So it looks like our gas that we used was 0.21 grams. So now to get our molar mass, we know the mass is 0.21 grams. Okay, now what we need to do, so we know that that's 0.21. Now what we need to do is we need to find the number of moles of gas. So we're going to use the PV equals nRT. We're going to use that equation to solve for N. That's the number of moles. But before we do that, we have to get our corrected water pressure. So what we would have to do is we'd have to go to the table that was in the lab. And so if you go to the lab, let's see here, I got to go to the table. There's a table, and let's see, this person, let's see if I can find the right video, not that one here. This person had 22 degrees Celsius, so if you go to 22 degrees Celsius, the correction for 22 is 19.8. You can see that right there. And so that's where we're going to get the corrected value is 19.8. So we're going to write that right here, 19.8. That's the contamination or the vapor pressure of water. So what we're going to do is take the air pressure that's collected that the barometer says 63.9.68, and we're going to subtract the vapor pressure of water. Whenever you collect a gas underwater, you always have to make a correction for the vapor pressure of water by taking the pressure in the room and subtracting the vapor pressure of the water. And if I do that, I get my corrected vapor pressure to be 719.88, and this is in the units of millimeters mercury. So that's my pressure, 719.88 millimeters mercury. Now, I also have to take my temperature and I have to add 273 because we're always going to work in kelvins. So 273 plus 22, that's going to equal 295 kelvins. So with gas laws, we're always working in kelvins. Okay, and this volume of the gas that we collected, it's going to have to be changed to liters. And remember that in 1 liter, there's 1,000 milliliters. So that's going to be 0.090 liters. Okay, now we're ready to plug everything into the PV equals nRT equation. So we have this equation, PV equals nRT. Okay, so our pressure is 719.88 millimeters mercury. Our volume is 0.090 liters. So if we're using the ideal gas law, the volume always has to be in liters. That's important. That's going to equal N. R is an ideal gas law constant. You can find the constants on page 4 on your formula sheet. And so when we're using millimeters of mercury, the constant is 62.4 millimeters of mercury times the liters divided by moles Kelvin. Sorry, this is messy writing. That's just one big long unit. And we're going to take that times the temperature in kelvins, 295 kelvins. Now, if we do the math, we basically have to get N by itself. So we're going to take this 62.4 and the 295 and move it to the other side of the equation. So what I'm going to do on my calculator right now is I'm going to take 719.88 times 0.09. Then I'm going to hit divide by 62.4, and I'm going to divide by 295. And when I do that, I end up with the moles of my gas. So I get that the moles equals 0.0035, and let's see here, that's as far as we can go probably because we have too many digits. So we got that many moles. Okay, now we're going to finish our molar mass. We know the grams. We're going to divide it by the moles. 0.0035 moles. And let's see what we get when we do that. So if we take 0.21 and we divide it by that answer, I get 59.7. So with this experimental data, I get 59.7 moles per liter. Okay, now butane is the gas that we collected, and butane is C4H10. So the true value would be the molar mass of butane is 12 times 4. So 12 times 4, that equals 48. That's the carbons, and 10 hydrogens. So we should have got 58. But with labs, there's always some experimental data. Okay, that's what we were supposed to get. Or we were supposed to get 58, this is what we got. So this lab data is pretty close. Okay, that's it. This is how to do the lab. Now what you need to do is to take the made up data that I have for you and see if you can duplicate what I just did, because you're going to have to be able to do a problem like this for the unit test. That's it.